So I want to talk about JavaScript Crypto, and I'm a freelancer, as you've just heard. I've done a lot of security projects in the past, and I actually love Ruby. And now you might ask yourselves, what am I doing at JSConf? Well, I love crypto, but I love JavaScript too. And I wrote a lot of Java crypto code in the past, and I wrote a lot of Ruby and C crypto code in the past, but I never wrote any JavaScript crypto code. Now, why is that? Is it because I don't like the language? Well, not really, because the reasons for that have been summarized pretty nicely in this blog article. I think you probably read that. It's written by Matasano. And note that they're just talking about client-side crypto. So it's totally fine to use something like Node.js doing crypto there, but the problem is on the client. Let's have a look at why it's basically doomed. In the general case, the JavaScript code is served over HTTP. So it's pretty easy for somebody to intercept the code while it's in transmission, and this man in the middle could do everything that they want. They could serve different files. They could change the files. They could inject code into HTML. Yeah, whatever they want. Now, okay, let's take care of that. Let's take care of the transmission. Let's secure the transport channel. We have HTTPS for that. This actually will work to prevent man-in-the-middle attacks because they can no longer snoop into communication there. But the problem is, what if somebody on the server side decides to go rogue? They could actually serve you bad files from the beginning. And this even doesn't matter if it's HTTPS or not, because they will just send the files on the server, so the transport channel doesn't matter. And the conclusion by Matasano is that if you don't trust the app to do the cryptography, which is what we basically do right now, so if you don't trust the app, how could you trust any JavaScript code that the app sends to you? So there's no difference in that, and they're right about it. And yeah, please note that this is not a JavaScript problem per se. It's just because JavaScript is being used on the client, and if it were any other language, they would have the same problems. But to be honest, there are some JavaScript problems as well. So most algorithms actually require you to do operations on bytes or 32-bit integers, and this is pretty complicated in JavaScript because we have no out-of-the-box support for that. And there's also no support for big integers, which is something that is really important for public key cryptography. And there are workarounds. There exist libraries that do this, but they don't have native support for this, so they're usually pretty slow. And there's also problems with JavaScript in the browser itself. The biggest problem is probably that we don't have a secure random number generator. What we have is math.random, but this is pretty predictable, and this doesn't help in the case of crypto. Because we really need, for everything in cryptography, we need secure random numbers. And if we don't have that, we just don't have to start with anything because it's trivially breakable. So there are, again, workarounds that try to induce real randomness by detecting mouse movements and stuff, but I don't know. This is clearly something that we should have in the browser by default, built in. So there has been recently crypto get random values, which is an attempt to provide a real random number generator that is secure. But as so often, the problem is it's not supported by everybody. So another problem with the language itself is that what makes it so fun, which is the same problem that also makes writing crypto hard, and that's we can change everything in runtime as we want to. So nobody prevents you from doing something like this. So if you think you can provide a better random number generator, you can simply override the built-in functionality. And this works with Firefox 23, actually. So there's nothing that makes this immutable. You can just override it. And this doesn't even have to be intentional. So let's say you're under pressure and you look at some code that you don't really understand and you try to optimize it, and something like this could happen. So you just override the encryption and you don't know better. And another problem is using something like JSONP or so, we often rely on remote code. So we can't really trust that code because they could just go on and override something that is critical for our security. So if we define random values on the server, the remote server could actually override this and do bad stuff with that. So the problem is our environment could change at any instant, and we don't have a good measure to actually verify its integrity. Now, I've shown you a lot of things that suck, but is this the end of it? And I don't think so, because we've seen recent developments that are actually pretty interesting. And we've seen attempts at providing something that gives us built-in crypto in the browser. One of those developments is asm.js, so it's not just good for playing Unreal Tournament, it's also good for doing exactly what we need in crypto, exact width integer operations. It gives us typed array support, which makes it really fast. And another major improvement that we've seen lately is the development of the W3C Web Crypto API. This gives us big integer support for RSA and other public key algorithms. And it also gives us this CSPRNG, the secure random number generator, and many other good stuff. So let's say this works in the future, but I still haven't told you why you should care. Why is this important to be able to do crypto in the browser? And I think with recent developments, one big subject that we all need to care about is privacy. So you've probably heard this sentence that privacy is not so important. If you have nothing to hide, then you don't need privacy. And I think this is total bullshit. Because, thanks. It's just a sorry-ass excuse to explain everything. And I think even in the audience, every single one of you has something that they wouldn't want us to know publicly. And the problem is we as social beings, we're often in a social context that is closed, and so we work problems out, and so we tend to forgive. But the internet stores it forever, so it does neither forget nor does it forgive. And it's really, really dangerous because today's surveillance is different than it was in the past. So in the past, you needed humans to spy on you. So you probably felt if your privacy was intruded. But today, it's more like nuclear radiation. You can't feel it if your privacy is violated. And this is not a matter of where you live or where you're born. It's not a state, it's not good states, bad states. I think the interest in our data is global, and we all have to care about this. So even if you think that our government is benevolent, it's not the government, it's the people that do the harm. So not the system is evil or the system is to blame, it's the people that are to blame. And they will abuse their power. It has happened in the past, and it will happen again. If you give somebody too much power, they start on snooping on their girlfriend or boyfriend, and it just sums up. So even if there's decisions that are meant to be good, the sum of them, because they're unrelated, may lead to something that slips out of our control. And this is what has just happened. So we create something that we cannot control any longer, and one of the problems is that a company, if you provide an application to the public, then you can implement perfect crypto on the front, but the agencies will just go in the back and they will get your data because you store it in plain text somewhere. And so this happens through extortion, or the data is sold, whatever, and it's a problem. Now the question is, are we powerless against this? Can we do something to protect ourselves? And I say we can. We have to start encrypting our stuff on the client. And to do that, we're going to need client-side crypto. And this improves things because even if an institution has leverage over a corporation, if they can extort them to hand over the data, it doesn't matter if we as individuals encrypted it. And it's not profitable to try to decrypt everything from every single human. Now, if this doesn't convince you and you still think that it's okay for them to have your data because there's nothing suspicious, let me try this. Surveillance will have an impact on your life, totally. And we will slowly graduate from something which we believe to be a good thing, innocent until proven guilty, to something more of guilty until somebody can prove that you're innocent. And it also puts determinism in our lives, which we certainly don't want. And there has been a case in Germany where a teacher wasn't allowed to become a teacher because she had to give her DNA sample, and they detected that she might be affected by a fatal disease in the future, and so she wasn't allowed to take the job. And I think this is pretty bad because you're held accountable for something that hasn't even happened and which probably is never going to happen. And because there are way too many people, they won't be able to put human beings on the profiling. They will have algorithms for that. And how would you feel about if you're being denied a job, or if you're even put in jail just because you have the same hair color than a mass murderer? And it conveys a false sense of knowing everything about you. Even if I know all the data from you that is online, I still believe that we are more than this. And we have our free will, we have our thoughts, and it's not just the actions that you see online. So they don't know shit about you, but they claim to know things about you. And if you're still not convinced, this is something that people often do. They put their vacation pictures on Facebook. So let me show you how this could go awry. Imagine that you put your bikini picture up there and you actually forgot to shave in the bikini area, and somebody notices this, publishes the picture online, and this goes viral, becomes a meme. Would you like that? No. And we always have to remember that the faces in memes are actually real people, and probably they don't like to be suddenly famous. And if we look at surveillance throughout history, I mean, we as Germans should know this. It's always been claimed that this is for the greater good, it's to protect us, but it never was. And to tell you a secret, not a single person felt safer there. It was the opposite. They were in constant fear because they were severely restricted in their attempts to experiment because they felt observed all the time. Now, if you try to use crypto, the answer is usually that it's bad, that you shouldn't do it, while at the same time, agencies claim that they need to do this in order to protect you. And this is always the excuse, and this just happened, I think, last week when an NSA official declared that they have to snoop on people because this is the only way how they can actually arrest child molesters, human traffickers, drug lords, and so on. But this is really an excuse. Do you think this is their major concern to, arrest human traffickers? I don't think so. It may be a byproduct, but it's certainly not the major operation. So this is just an excuse. And there's this imbalance. We are supposed to be completely transparent, while at the same time, agencies are allowed to have secrets. And I think this just doesn't work out. I would say they should have their secrets because this protects the operation of agencies, but at the same time, we should be allowed to have our secrets too. And I want us to move back to something more of mutual trust. So by default, the government should trust its citizens and not the other way around. And this is really scary. Some German politician actually claimed in public that he believes that security is more important than our personal freedom. And again, I think this is bullshit because your personal freedom is some form of security. And I think if they take this away, then there can be no security at all. Now, let me give you a quick excursion of something that would totally solve this for good, and it's called homomorphic encryption. A homomorphism is a mathematical function that maps from one structure G to another structure H. It implies two operations in G and H, and the clue of it is that applying the function to the combination of those two elements will yield the same result as applying the function to the elements individually and then combining it. Pretty complicated, so let me give you an example. So for simplicity, let's say our homomorphism is 1 over x, and G and H are the same thing, the real numbers as you know them. And the two operations are actually also the same. They're the multiplication in real numbers. So if you just simply write out the definition, then f applied to a times b is 1 over a times b, which by the laws of multiplication is 1 over a times 1 over b. And this is actually the right-hand side of the definition. So 1 over x is a homomorphism. We can find this in crypto too. RSA is an example for this. As a quick recap, RSA encryption is defined as having a public key E, a modulus M, and then the encryption is just taking x to the E and then taking it modulo M. If we look at this using multiplication again, then this will again be a homomorphism. So the encryption of x1 times x2 is x1 times x2 to the E. By the laws of exponentiation, we can pull in the exponent there, and by the laws of modular arithmetic, we can apply the modular operation individually, and then again, we have the right-hand side of the definition. But if we try the same thing for addition, it won't work out, because there's no law that would allow us to do the last line there. So this holds true in general. It's pretty easy to find a homomorphism for one of the operations. So in mathematical fields, you usually have two operations, for example, addition and multiplication. And you find something for one of the operations, but it's pretty hard to find something for both. And this would be called fully homomorphic encryption. And the definition there is just extended by another operation. So you look at two operations at the same time, and this equation has to hold for both operations. Now, you might ask yourselves, why is this so important? Well, it preserves the ring structure of the original structures. To put this in simpler terms, think about it as it allows you to do algorithms on encrypted data yielding encrypted results, and if you decrypt it again, it makes sense. So a good example would be Google search. So if we had something like fully homomorphic encryption, then we could actually put in our search terms, Google would get this encrypted, would perform the algorithm, would produce a result which is still encrypted, and only you can decrypt the result and it makes sense, and Google won't learn anything about your search. Of course, this can be abused, but I think the advantages outweigh the disadvantages, and this would really give us privacy deluxe. And the question has been for a long time, so many people have claimed that this is not possible at all, but then last year, this guy made a major breakthrough and actually found a function that just allows us to do this. But it's still rocket science, and it won't be available in decades until we can use this in everyday programming. So the question is, what can we do right now? And this is an example. I've worked a lot in the past with the European Commission, and the European Commission tries to introduce those EID cards in every European country. And the idea is to do tax forms and stuff like that online without requiring you to go to an office. And this is all great, but somebody forgot to think about how we would use this. And the problem in a browser context is the only way that allows you to access smart cards is by using Java applets. And this worked for some time, but after last year, I don't think, with all the security problems, nobody wants to use applets anymore. Now, Firefox had this experimental access to smart cards, which is pretty cool, but nobody picked it up. And this is something, please, browser people, think of us Europeans so that we can use smart cards, EID cards from the browser. This would be really cool. And the advantage is that we actually have a secure device that stores the keys, and applications could no longer access the keys on that device. So it's a real improvement. And I also believe that we are the only people that can actually assess the dangers and risks of all these privacy intrusions. So we must fix the problems. The general public doesn't care because they can't really understand the problems. For example, many have advised us to use PGP as MIME for emails, to use client-side encryption tools. But I ask you, how often did your relatives, your mom, your girlfriend, your boyfriend use this actually? And so I'm saying this opt-in is not going to work. Nobody is going through the ordeal to install all that shit on their computer. What I want is for my mom to go online, and it should all be secure implicitly. So she doesn't need to do anything to be secure. And also academia must help us fix this problem. For example, we had sharing schemes. They are already present, and they would allow us to render extortion useless so that it no longer works to just extort one specific person, but they would have to extort many people at the same time. And this is much harder to do, and so this would render this whole business useless. And I want something like one-time encryption. So if you think of the messages in Mission Impossible, you read it and then it dissolves into thin air. And the same thing is being researched in cryptography because it's really hard to do with mathematical tools, but there has been some nice research, and I think this would be perfect for secure chats or something like that. So you receive the message, and after you read it, it becomes useless. Nobody can decrypt it anymore. And I want to encourage you to use the Web Crypto API. I think it's a major step forward. Even if, as we saw at the beginning, there's no real difference between application-side crypto and client-side crypto right now, I still think it's a matter of trust. So even if you do the crypto on your local machine using local tools only, you still have to apply trust at some point. Because who tells you that your browser or your operating system is actually secure? Have you looked through all of the source code? Have you compiled it yourself? And I think this is a chicken and egg problem. Because, of course, you can do HTTPS downloads, you can put a signature on the package, you can verify that signature. But in order to verify the signature, you again need some piece of software, so you would have to do the whole verification process over again. And this, yeah, is just not solvable. And that's why I believe that client-side crypto using something like the W3C API still is an improvement, because mostly it doesn't allow the app to use the keys anymore. They can't look into the keys. They don't see our passwords. And so it's really an improvement. But the problem with this API is it takes all of this code just to encrypt a little piece of data. And this just calls for implementation errors. And unfortunately, it's a low-level API like OpenSSL, which gives you full control, which is a good thing, but it also gives you full possibility to shoot yourselves in the foot. And worst of all, there's no security faults. So you have to figure out yourself what works and what doesn't. And I'd rather want something like this, which is easy to use, high level. You generate a key, then you encrypt your data, and you're done. Because I believe that, sure, we can all acknowledge that crypto is hard, and it certainly is, but I don't think that the APIs surrounding it have to be hard and complicated. And that's why I work on a project, which is a Ruby project still, which is called Crypt, and the idea is to provide a framework that wraps all those low-level APIs and exposes a higher-level API that makes crypto understandable, easy to use, and it's secure by default, so you don't have to figure out all the parameters. And I think we need the same thing in JavaScript. We're gonna get the W3C API. It's too complicated. We need something that is more simple to use. And so I think something like a grip.js would be a good idea. So that's it. Thank you.